Hello students, welcome all of you at AriserTalent. So in our class 10th chemistry chapter number 3rd, that is metals and non-metals, we have discussed about the reactivity series. We have seen for the corrosion and its types and what are the ill effects of corrosion. We have also discussed about the extraction of the metal and the various activities or the processes related to the extraction of the metal, that is called metallurgy. Now in our today's lecture, we are going to discuss about how do metal react with non-metal and form the ionic or electrovalent bond. So today we are going to discuss about the ionic or electrovalent bond. So in this chapter or in this topic, we have to acquire a small knowledge about the periodic table. That is how elements will form their octet, how elements will form their duplet. So we are going to start our new topic, how does metal react with non-metal. So our today's topic is how metal react with non-metal. Now the question is how metal is going to react with non-metal. So firstly, an octet rule, that is in the periodic table classification, was given by Kota and Lewis in 1916. According to this rule, when an atom or element has 8 electrons in its outermost shell, it is considered as a stable atom and it do not need to acquire any more electron because it is chemically active or chemically stable, so it does not need any extra electron to give or take. So an octet rule is basically given by Kota and Lewis. So in this topic we are going to discuss about the octet rule. So this octet rule is specifically given by Kota and Lewis in year 1916. And according to this rule, an atom or the element must contain 8 electrons in its outermost shell. So the rule is element must contain 8 electrons in its outermost shell. So if 8 electrons are present in the outermost shell of an atom, we can say that its octet is complete. So completion of the octet will lead to either the chemical stability of the atom or make the atom chemically neutral. So to judge the chemical reactivity of the metal, we have to check either its octet is complete or not. Noble gases like neon, argon, krypton are chemically inactive gases, inert gases, because they have their complete octet in its electronic configuration. But there is one exception, that is helium, which is basically an inert gas or the noble gas having 2 electrons in its outermost shell. So we can't say that its octet is complete. We can say that helium atom will have its duplet complete. So what is the exception here? Exception here is helium. Helium is He and it contains 2 electrons in its outermost shell. So we can say that its octet is not complete, its duplet is complete. So this is known as duplet. And the element which have 8 electrons in the outermost shell are considered as a octet. Now we can see some of the example of the elements or the noble gases which have 8 electrons in the outermost shell, and we can say that whose octet is complete. So we have taken the general elements here. here we are taking element, here atomic number, electronic configuration, now if I am considering an element called neon, neon is an element having atomic number 10 and its electronic configuration is basically 2, 8. Second factor I am considering here is second example we have considered here is argon. Argon is having an atomic number 18 and for the 18 electronic number the electronic configuration is 288. Now we have our next element that is called krypton, which is also an inert gas. So for the krypton, third element is krypton. Krypton is having an atomic number 26. Krypton is having an atomic number 26 and its electronic configuration is generally 2, 8, 18. So you can see here these are the three noble gases, that is neon, argon and krypton, and in neon, argon and krypton we can see here the outermost shell has contained 8 electrons. So these 8 electrons we can say that its octet is complete and it leads to the extra stability of the atom and it is chemically inactive. So we can conclude that these kind of elements or atoms do not need any extra electron to acquire to complete its octet. So this is all about the octet rule that is given by Kosal and Lewis. Now if an atom has to complete its octet or duplet, it will take the extra electron from the neighboring atom or element to complete its octet. So this will be the conclusion. So we can see here these noble gases will have the 8 electrons in their outermost shell. So we can say that their octet is complete and they are chemically active. They do not need any extra electron to acquire from the neighboring atom to complete their series. Now if an atom has to attain a chemical reactivity or the chemical action, there must be 3 necessary conditions essential for atom to acquire stability or to attain the stable noble gas configuration. So the 3 conditions are, we have 3 conditions to acquire stable inert gas configuration. So the 3 conditions which are necessary for the stable inert gas configuration are, first condition is by losing an electron. Second condition is by gaining an electron. And third method is by sharing. So these are the 3 basic methods by which any atom or element can achieve the noble gas configuration or the inert gas configuration, and the 3 conditions are by losing an electron, by gaining an electron or by sharing. So this is all about the octet rule and how atom can be extra stable. It means chemically stable, so it can be either be by achieving an electron or by losing an electron. Now we can look for the another topic, that how the bonds are formed, which is the main topic of our today's lecture, that is ionic and electrovalent bond. So now we are going to discuss about the formation of bonds. So before this, you can copy it from here. So our next topic is concept of bond. So in the concept of bond, we have seen that noble gases have 8 electrons in their outermost shell and their octet is complete. They do not need any extra electron to gain or lose from the atom. Now concept of bond is basically is that in the periodic table, except group 18 elements, all the other elements are not independent in nature. They are chemically active only when they acquire or lose the electron from their outermost shell to complete their stable noble gas configuration. So if an element have a tendency to lose the electron, we can say that these are electropositive elements. If the atom has a tendency to gain the electron, we say that they are electronegative element. Now the bond is formed between the electropositive and the electronegative element is known as ionic bond. So now we are going to discuss about the concept of bond. So what is the first point of consideration here? Except group 18 elements of the periodic table, all other elements are not stable, and they will attain the stability only by gaining or losing the electron. So second point is they will attain stability by gaining or losing an electron. We have already discussed that the gaining of the electron are electronegative elements, and which have the tendency to lose electrons are known as electropositive element. So the next point is elements losing electron and elements gaining electron. So tendency to lose the electron is known as electropositive element, and if the element have a tendency to gain electron, we can say that element is electronegative element. So by gaining or losing electron, a bond is formed between the atom, and the bond which is formed between the electropositive and electronegative element is known as ionic bond or electrovalent bond. So we can say that ionic bond is always formed between the elements of or the ions of opposite nature. One must be positively charged and another one will be the negatively charged. So this is all about the concept of bond by sharing of electrons, by gaining of electrons or by losing of electrons. So what actually the ionic bond is? We can say ionic bond or electrovalent bond. So this ionic or electrovalent bond is which is formed by electropositive and electronegative element. So this type of bond is formed between electropositive or electronegative element. So ionic bond is basically formed between the electropositive and the electronegative element, and it is also known as electrovalent bond. Now we will look for an example for the ionic bond or electrovalent bond. So it must be clear to you how this ionic bond is formed between the different kind of the atoms. But the condition necessary is one must be gaining the electron and another must be losing the electron. So the process of gaining or losing the electron will go on continue, and sometimes cations are surrounded by anions and sometimes anions are surrounded by the cations. Now we are going to discuss about the example of ionic or electrovalent bond. So I hope the concept of bond has been clear to you from these points. Now we have example of ionic bond. For discussing the example of ionic bond, we are considering a simple example having a crystal lattice arrangement of NaCl, that is sodium chloride, and we will see how sharing of the electrons will be done by gaining or losing electron, and how the electrovalent or ionic bond is formed between this type of the compound. So what example we have considered here? We are taking an example, common salt, and common salt is actually NaCl. Now we see here it is formed by the two type of the compounds, that is sodium and chlorine. So for in step number 1, we are discussing about our step that is called sodium. Now sodium is having a symbol Na. Na is having atomic number 11 and its electronic configuration is basically 281. So what is here? This sodium is having an atomic number 11, and for this atomic number 11 we have the electronic configuration that is 2,8,1. Now if I draw the electronic representation of this diagram, we can see here this is Na and its outermost shell will contain 1 electron. So how the electrons will be drawn here? It means firstly it has 2 electrons, then firstly it is having 2 electrons, then it is having 8 electrons, and lastly it is having 1 electron. So you can see here, firstly sodium will have 2 electrons, then it will have 8 electrons, and lastly it will have a 1 electron. So this is 2 electrons, these are 8 electrons, and this yellow part is its 1 electron. Now what will sodium will do? Sodium will have a 1 electron in its outermost shell. So we can see that it will complete its extra stability or acquire stability only by losing that electron, because by losing that electron the electronic configuration of the sodium will be 2,8. So it must be possible to lose 1 electron in spite of gaining 7 electrons from the neighboring atom. So what will sodium will do? Sodium will going to lose that electron and attain extra stability by having 8 in its outermost shell. So what will happen? Sodium is going to lose that electron. Sodium will lose that electron and it will form Na. Again it is having 2 electrons and remaining 8 electrons these are 8 electrons. So sodium is losing that outermost electron, so we can say that it will become Na positive. Why I am putting positive charge here? Because the electropositive element have a tendency to lose the electron. So sodium will now going to become the electropositive element by losing 1 electron, and now before its electronic configuration is 2, 8, 1, now its electronic configuration is 2, 8. It means it is attaining extra stability by completing its octet. Now you can see here the amount of energy required or the amount of energy needed for this process is known as ionization enthalpy. Ionization enthalpy is basically an energy required to lose an electron from the outermost shell. So we can say that what it is needed here plus IE. IE means ionization energy. So ionization energy is actually the energy. This is ionization energy. And this ionization energy is actually the energy required to lose an electron. So we can say that it is the energy required to lose an electron. So this is all about the sodium we have considered here. Now we are going to discuss about our next element that is combining with sodium, and that is chlorine. So we are discussing chlorine now. Now our step number 2 is sodium is combining with chlorine, and chlorine will have a symbol C, Cl, capital C, small l. Now we can see here chlorine is having an atomic number 17. Its electronic configuration is 2, 8, 7. So what we are going to do here, firstly this is chlorine. It is having an atomic number 17. For the atomic number 17, we have an electronic configuration that is 2, 8, 7. Now, for this 2, 8, 7, we can see the electronic concept by drawing electrons. So, what we are doing here, we have taken chlorine. That chlorine will have 2 electrons. Next, 8 electrons. And finally 7 electrons in the outermost shell. So 7 electrons are distributed as 1, 2, 3, 4, 5, 6 and 7. So this is the electronic structure for chlorine, that 2 electrons, 8 electrons and the 7 electrons in the outermost shell. So it will not be possible for chlorine to release 7 electrons to attain the extra stability. It will take 1 electron from the neighboring atom to complete its octet to form the stable compound. So what sodium will do? Sodium will take 1 electron, and that 1 electron will be taken from sodium and chlorine will form its octet. So what is the basic structure for chlorine now? This is chlorine, again 2 electrons, then 8 electrons, and now again 8 electrons. And chlorine will acquire the negative charge because It is electronegative element acquiring some sort of electrons. So you can see here, this is the basic electronic concept about chlorine, and sodium will donate its one electron to chlorine, and chlorine will acquire that electron to complete its octet, and the compound formed here will be NaCl. So we can see that Na positive plus Cl negative is going to form NaCl. Now, energy required for losing an electron is termed as ionization energy, but in this process, energy required to gain an electron is known as electron affinity. So here, what is happening here? Here energy is gained. Here energy is required to gain an electron. So energy required to gain an electron is termed as electron affinity. So we are discussing the next term here. This is the energy to gain an electron. It is known as electron gain enthalpy. So electron gain enthalpy is basically the energy required to gain an electron. So this is all about the two energies we have discussed here. Ionization energy is the energy required to remove an electron, and electron gain enthalpy is basically energy to gain an electron. So this is all about how the ionic bonds are formed. It is formed by the electropositive and electronegative element, and we must see here that ionization enthalpy must be less than electron gain enthalpy. So this point is of the much important, that ionization enthalpy must be less than electron gain enthalpy. So this is how ionic bonds or electrovalent bonds are formed. Now we are dealing with the properties of the ionic or electrovalent bond, but before discussing this, you can copy it from here.